the Kaggle assignment for the MLP course. So first, these are all the libraries which are there to install. Then I loaded the train data and test data into DF and test DF. First, I checked all the data types of different columns in the database, like ID, airline, price, and these are all their data types. Then I have performed the descriptive statistics using the df.describe, in which I get all the statistical analysis of the numerical columns which are there in the data set. Like duration, I'll get the count, mean value, what's the minimum value it's holding, what's the maximum value it's holding, and similar for all the numerical columns. Then I'll check handling missing values. I'll check is there any missing value in the data set, and using the is null function. And I found that there are some missing values in the airline and the departure stop and many other columns. So the approach which I'm following to handle the null values is to for the numerical columns, I'll impute the null values with their mean value, and for the categorical columns I'll impute them with their most frequent or mod values. So I'll doing that using this. First, I'll separated all the numerical columns in the dataset and all the categorical columns in the dataset, and then using the for loop, I first calculated mean value for the numerical columns, and then using the fill NA, I have filled the null values with their mean values. And similarly, in the categorical columns, I've first created the mod value using the dfcall.mod, and then fill those mod values at the place of n. And after imputing, I've again checked is there any null values. After replacing all the values, then I again typed it, and it says there is no null values. Now I identify all the duplicate values. Is there any duplicate value in the data set? And here I have performed the df.duplicate, so there is no duplicate data in my data set. So now I have defined a new variable train data after all these pre-processing. So now I will be using this train data for further processes. And then I'll identify outliers. I'm using IQR method, interquartile range method, to identify the outlier. I'll first calculate the Q1 value, 25th percent quartile, and then 75%, and IQR Q3 minus Q1, and then I'll set a lower bound and upper bound and identify all the columns which have values crossing these lower bounds and upper bounds. So, and I'll be saving them in this variable outlier indices, and then I'll be printing all the columns with their outlier values. Like here I have found that the duration has some outlier values with these columns are outliers, and in the price I am having the outlier values. Then for to handle the outlier value, I first converted all these data in these columns, duration and prices, into numerical values, and then plotted the box plot to get a visualization about the outlier values. So here this is the outlier values for the duration. So these are some outlier values in the duration column, and in the price these are some outlier values. And then I calculated the outlier value, like percentage of outlier values, to understand that how can I handle it. So it came out that in the duration column, the percentage of outlier values is 0.01%, which is low, and in the price it is also 0.0003%, which is also so less. So I think I could drop them. So I written this for loop to drop all those values which are not in the lower bound and upper bound. I set all the values to be in the range of lower bound and upper bound. And after dropping all these outlier values, I plotted the box plot again to visualize that is there any outlier value still there. So yeah, there is no outlier value in the duration. It's outlier free. It's outlier free. But these columns are not perfectly outlier free. That if I analyze them on their like a price value, I'll identify on the classes basis, then there is only some outlier. But in the price general way, there is no outlier. So yeah, we can say that it's outlier free data. Now I visualize some graphs. So first I checked the distribution of the price, and it came out that there is distribution. This is the graph. So there are prices. There are many flights with low prices, and for mid range there is less flights, and for higher range there are many flights. So we are not having the normally distributed data for the price range. We are having two peaks here, and we can also see that here that for the less price we are having much data, and also the mean is into the less side. Yeah, that's also understandable with the box plot. Then we have distributed the ticket price based on their airlines, like there is Vistara, Air India, SpaceJet, Air Asia, Indigo, Coast, Hertz, and many more. So we have analyzed that for Vistara, they are offering price range a little lower, and then mean is also lower. So this is the distribution of ticket price based on their airlines. and then we have plotted the ticket prices based on their stops. Like if the flight stops for there is one stop for a flight journey, there is two stops, and there is two or more stops. And it's understandable that for less stops there will be higher price, but it is surprising that for zero stop there is less average price than the one stop. So this is, I think there should be this high, but it is the data same. And then we have plotted the box plot for the price distribution by class, like business class and economy class, and we can clearly see that the mean price for the business class is higher and for the mean price of the economy class is less. The upper bound is also not reaching to the lower bound of the business class, so it's quite understandable. Now we have to perform some numerical features and some analysis and processing of the numerical and categorical features. So first we have checked that what are the columns in our trained data set. So these are the columns in the trained data set. Then we have split that into x and y. Our price is our target feature, so we have put that into y, and all other features are into the x. So these are our features and price is our target. So we have started to prepare a pipeline for the numerical columns. We will be following that. We will be firstly imputing the with simple imputer with the mean strategy, and then we will be scaling them using standard scaler. And for categorical columns we will be imputing using the simple imputer or most frequent strategy, and then using the one hot encoding we will be encoding the data. And then we have used the column transformer to make the pipeline. And for numerical columns, first we have in the earlier columns we have defined the numerical column, and then we will set these numerical pipeline transformer for the numerical columns, and for categorical columns we will be doing the categorical transformer. And this way we have prepared our pipelines for the processing and scaling and encoding of the features. And then we have decided will be building the models. So first we will be splitting our data into training and validation data set, and we have decided to go with the 8 models: linear regression, KNN, decision tree, random forest, gradient boosting, ADA boosting, XG boosting regressor, light BGM regressor, and we will be storing their results in the results, so that can be used for further analysis and comparison of the models. So we will be using those pipelines which we have decided earlier. Here, preprocessor. We will be processing the data and then training with that model, and then fitting, and then we'll be predicting the x valid or prediction on the validation data set, and then after that we'll be calculating the R2 score and root mean square value, and storing them into result. And we have came out that for linear regression it's 0.92, for KNN it's 0.892, for decision tree it's 0.958, and similarly for the other models. So first we will decide the top models, and we have sorted them out based on their root mean square values. So it came out that the random forest, XGBoost regressor, light GBM regressor are the top 3 performing models on the dataset. So we will be using grid search for their hyperparameter tuning for the top 3 models. So first is the random forest. We will be using the grid search CV and deciding their parameter like an estimator between 50 and 100, maximum depth between 10 to 20, and then fitting for the best data set for the best estimator values, and then we're predicting and calculating the root mean square value and R2 score, and then storing them into result variable. And after hyperparameter tuning, the R2 score is coming 0.973, which is slightly lesser than the before parameter tuning. And then we will be coming to the XGB regressor, and similar process is there in this. And for light PGBM, this is all the hyperparameter tuning which we have done. And after for comparison model, we see that after all the models which we have trained for XGB regression, after tuning, the R2 score coming out to be 0.9764, which is the highest among all the models. So we will be training our dataset on this tune XGB regressor model. So we'll be predicting on the test data. So we will be first loading the test dataset in the test variable, then we checking the shape, and then for the best model is the XG grid, which is tuned model. In that here we have defined it as XG grid as the best model after tuning. So we have used that, and with the best estimator and predicted values of the test dataset, and we have prepared our submission in the given format and submitted that. So this way I have submitted my Kaggle 1 assignment.